Hello and welcome. Um, Not having an awful lot to record in this. My phone has gone off, so for those of you who are wondering, I'm having to re-record this again. But I wanted to run you through a few things. Basically, we're using this is Starry Night. It's Starry Night Cottage 6 I'm using, and I wanted to go over a couple of things for home educators and for beginners because there's some interesting things in the night sky at the moment, and plus a few people I think are struggling with telescopes, and I thought I might better explain some of it here. So here we are, we're looking south, and it's about, well, real time now for me at 20 past 3, and I'm speaking to you in Northampton, which is where my stood my I keep saying Stellarium. This is Starry Night. I will say this is Starry Night, not Stellarium, and I apologise to Starry Night if I keep slipping like that. It isn't on purpose, but they gave us a key to this. They sponsored us generously last year, and I wanted to return the favour with a plug. Very good planetarium software. I'm not just saying that because they've given it to me, but I've been getting on with this for several years. So anyway, without further ado, let's plug on what we're looking at. Well, at the moment, there's some interesting things going on in the night sky, and as it's getting darker earlier, the festivities are over. You might have a pair of binoculars or a telescope for Christmas. You're wondering, well, what do I do with this, and what can I see with it? Hoping now to run you through a few things. If I speed up time to about, say, 300 times, you can see the sun's beginning to set now, but a bit slow for me. Let's go for 3000. Bit quicker. Things are disappearing now into the western sky, and here we are. I'm going to pause now at 1825 because we can start seeing some things happening up this way. And if we come across here to the east, this is where stars are rising from. So if I go into sort of more, let's go to 30 times. It's not really discernible from here, but you know it is still. The sky is still rotating. You've got an object there that's disappearing off. Can't cache it. I think it's probably a satellite that. But here, what you've got is you've got the constellation of Orion that's rising, and at about 6:45, it's still quite low in the sky. So let's go a bit further forward, faster forward. And there we go. It's getting a bit better. There are other constellations we could look at, but this is the main one. So if we sort of say roughly about half past, there we go, 20, that'll do. 2 minutes aren't going to make much more difference. That there is Orion the Hunter, and it's a very, very conspicuous constellation in the night sky. It is my favourite. It's caked with bright stars. You've got the 7 bright stars around the area here. If ever they're asking you to do a light pollution check to see how many stars you can count in this area, in the constellation of Orion, this is the constellation they're talking about. It's a lovely winter constellation. It is my favourite. It's the one I started off with about 30 years ago, the first one I saw, and it is unmistakable. I mean, in light pollution as well, you can see those 7 stars, and for me, you know, it always tells you when winter's on its way. When you see that just after midnight rising in the east, you know that winter's coming. Many farmers will go by trees and leaves, but for me as an amateur astronomer, Orion has told me to start saving. Winter's coming, Christmas is on its way. And there it is, and why not? It's a beautiful constellation, that one. It is Orion the Hunter, and this is his main body. And over there, I wish I had some sort of pointer. I don't think I have with this, unfortunately, but that's the bow. He's shooting into the bull here, and behind him he's got his dogs. So let's move a bit forward and let his biggest one rise a little bit more, because that's worth seeing as well. And there she comes. Let's pause it there for a second. So what have we got here for the binocular enthusiasts then? Well, this is southeast into the skies. It's still reasonably low. We want things to be ideally up here to be well placed at the southern end, but this is good enough for most people who've got a clear sight to the east. Up there you've got a star which is called Betelgeuse, or Betelgeuse as some people call it. It is a bright star, but one of the brighter stars in the sky. Brighter, not the brightest. In fact, on that note, Sirius down there is, but Betelgeuse is still a bright star, and it's also a very massive star. Its radius is 667 solar radii, which makes it pretty big indeed. In fact, it's a supergiant, which means if it's in our solar system, it would swallow up most of our solar system up to the orbit of Mars, if it was where our sun is at the moment. It's a star that's coming to the end of its life pretty much it's dying as our sun will. I mean, if you want to see what our sun's going to look like in several billion years, then check out Betelgeuse there. That's going to be the fates. And yes, but don't worry, that's not going to happen in our lifetime, and probably not that of your children or your great-great-grandchildren. Far more important things to worry about before that happens. But that's what's happening there with Betelgeuse. And it'll probably leave us a nice little ring nebula afterwards that'll please amateur astronomers for millennia to come afterwards. But still, if you look at it with a pair of binoculars or a small telescope, you'll see that looking as a very charismatic or characteristic red colour, but very well worth taking a look at. Down to the right, there's Bellatrix, but if we come down to his belt here, which is marked off by Ornithak, Ornilum, and Mintaka. Always try to memorise the star names if you can. Looks good at parties. There's a nice little party trick. But down below from the belt, you've then got another 3 objects kind of coming down this way. And in there is something called the Great Orion Nebula. M42 we call it, named after Charles Messier's catalogue. That's another story, but he catalogued that because he kept mistaking it for a comet. Don't ask me how or why, but he designated it Messier 42, otherwise known as M42, the Great Orion Nebula. And that nebula is probably one of the most heavily photographed objects, heavily observed objects, other than the moon in our night sky. It's dead easy to see with the naked eye, and certainly worth the punt. If you've got a pair of binoculars, it shows as a slight misty patch. If you've got a telescope, you'll see some structure. It'll be black and white because our eyes can't resolve that colour. But if you put a small telescope on there, you'll see the overall shape and structure of the nebula. And if you want to get some colour out of it, then stick a camera at the end of your telescope and expose it for 45-50 seconds or so. And depending on your setup, you'll start to see some structure and colour coming into place if you're shooting it in colour. I'm not going to go diverting too much. I'm just going to cater for all sorts of audiences really. But that's certainly worth taking a look at. And what it is a star was there before, came to the end of its life, poof, blew up, left all this gas behind. Should have a picture of it really, but I can't seem to pull that up here easily. And nebula was born, and stars have been born in it. And those stars, when they become fully fledged stars and able to fend for themselves, they'll blow off all the other gas and leave a nice big cluster of stars behind. Not a lot different to the Pleiades that we've got up there. So you've got the Seven Sisters. Again, it's another great binocular object. Not so good with telescopes, but binoculars show this very well. Telescopes should probably struggle to make out the full structure. It's probably one of the few objects as well where it really is better to get a pair of binoculars than assault it with a telescope. So again, this is also a good naked eye object. In fact, a good challenge for your eyesight is to see how many stars you can see. So see how many stars in the area you can count. In fact, I believe it used to be a test for Roman soldiers before they got admitted into the army, to count how many stars that they could count in there. I mean, don't quote me on it. I read it. Somebody I think told me, or I read it from somewhere who probably got it from somewhere else. But nevertheless, it would be a good test for your eyes. I mean, just to give you an idea, I'm as blind as a bat anyway, and even with my glasses on, I struggle, which is why I tend to cheat these days and use a telescope over a naked eye, because I can't readily see the stars thanks to light pollution. So there you go. But some of you, on the other hand, can. So this is also for you. Now, without further ado, I can hear you shouting at me, what is that smudge over there? What is that tail thing? That, ladies and gentlemen, boys and girls, is what we call a comet. And one of the reasons why I wanted to record this for you this evening, or this afternoon even, because we're hopefully going to get some clear skies coming tonight and into the month, and that comet is up there for your perusal. And I'm certainly looking forward to seeing it. It's gradually climbing up into our hemisphere now. It is going to move further north. And in fact, if I can possibly maybe pull it up, can I? Maybe not while I'm recording, but I could. The orbit runs up that way anyway, so it is coming further north, but it will get fainter as time goes on. But at the moment it's there. It's not howling the way hell Bokbokai Hutaki was, but it is there. And anybody with a pair of binoculars under dark skies should see it with a People have taken reasonable pictures with it as well using a DSLR camera, and of course it should be a decent telescope object too. So certainly worth taking a look at that. So if you look sort of east, southeasterly at 8:30, then there is the comet there for your trouble. So certainly worth taking a look at that. I'm going to move on now to just sort of showing you how the sky actually moves, because I noticed some home headers and beginners are a bit confused by that and how and why it does it. Well, we all know there's 24 hours and stars rise in the east and set in the west. None of them stay up for longer than a prescribed time. They all sort of rise to their glory as Orion is at the moment, as it gets to its fullest southern extent. It will do that earlier as we're going through the year, but at the moment at about 10 o'clock it's about as well placed for you as it's going to be. Jupiter's not far from it behind there as well, just for your interest. But basically the point is that you've got, that's where the heavens tends to rise and set. They're not circumpolar. What's circumpolar? Bear with me, I'll show you that. But if you're an amateur astronomer looking to buy a new house or rent a new house, whichever, try and get a south-facing garden for this reason, because things rise and they set. So that way you're not presented with the same constellations all year round. But what do I mean by that? Okay, well let's just pause it for a sec, and then let's whisk north. And now I'm going to discuss with you what circumpolar actually means and why it's important to align telescopes, and give you a bit of a pointer as to what the North Star is. Now if I come a bit further down here, I'm not going to turn on the lines because, well, there's no lines in the night sky when we're actually looking. But if you look closely, pardon me, you might see 1, 2, 3, 4, 5, 6, 7 brightest stars over there to the right. That is part of the Great Bear. In fact, there's more of it than just this asterism here. You've got the legs down there, you've got the head over there. It's quite a big constellation, but the main part which we see and recognise is that part, and it gets called everything from the plough to the frying pan. Personally, I haven't seen too many ploughs, but I have seen frying pans, and yep, to me that looks more like a frying pan or a saucepan. And it's called Ursa Major, the Great Bear, and it's a very, very important constellation indeed. And if you only learn the name of 2 stars in here, learn that one, which is Merak, and learn that one, which is Jupi. And always look out for that constellation if you're going away hiking or somewhere like that, or if you're a Boy Scout or in the Girl Guides. This one will help you get your astronomy badge. That constellation there, if you take the 2 end stars, Merak and Jupi, and draw an imaginary line across, you bump into another one, which is the brightest star in the area. And that is the tail end of another constellation called Polaris. Ursa Minor, sorry. Polaris is the name of the star. Ursa Minor is the name of the constellation that is the tail end of. So in there, pardon me, that there is Polaris. And it's aptly named because it's our pole star. And we're lucky here in the Northern Hemisphere compared to the South in terms of having that, because if we accelerate things on, you'll see we're a little bit, but it's not exactly telltale. Let's go a bit faster, shall we? You can see that things by now are moving, and our pole star is generally quite, going to lose it in a second anyway to daylight as the sun rises and sets again. But if we come back in, just bear with me for a bit. Getting darker, and there it is back there. And if you look, all the stars are orbiting or appear to be going around that star there. That appears to be quite stationary, and all the other constellations and stars are going around that, because that is where our celestial pole is. It passes straight through the Earth because the Earth is rotating, and that is why the stars constantly move through the sky. It's not because the stars are moving, it's because we are. We are moving around and around approximately a 24-hour cycle, and our Earth's axis passes roughly through there, going straight through the Earth down to the southern end, what you call the nadir, roughly the exact opposite to that. If you're at the North Pole, straight down is the South Pole. It's about that axis that the Earth is rotating, and to give you an idea, if you get a football, or if you get a marble or something and spin it, you'll see it moves around an axis. And after all, when it runs out of energy, it starts to fall off its axis. That's precision. Our Earth does that as well. But it's through that it's through that round about that the Earth rotates. And if we go a bit faster, just to confuse you a little bit extra, you'll see that even Polaris itself rotates. It's not dead stationary, and that is why even the more fancier telescopes don't align exactly to Polaris, but they use Polaris as a guideline to be aligned dead in the centre of a nothingness mark, which really is where our northern celestial pole is. So when you get a telescope that's equatorial, what we need to do is we need to align it north. And when they say align it north, this is where a diagram would be handy, but if you've got your manufacturer's book, it'll tell you. You need to get your polar axis aligned to that, and you need to get it at the right latitude for where you are. So I think Northampton's roughly about 51.5 degrees thereabouts. It might be a bit higher, I have to double check. And what that basically is that's a number of degrees down from the North Pole. So as we come down, obviously the pole star is dropping down and down and down. So it's the degree there that we're interested in, and we need to get the equatorial mount to that latitude there. So if you can move your bolt to get it to roughly what your latitude is, 51.5 degrees I think is for London. We're slightly we're different to that here in Northampton. So whatever it is, if you use Scope Help, an app on iPhone, it will tell you what your latitude is, and that's the angle to set your telescope to roughly. And then depending on the type of mount you've got, some of them have just got, that's it. There's no polar scope or anything like that to help you. So you just have to align it as accurately as you can by eye to that star. But that's no big deal to a point, because it's only really for observation purposes. It's never going to be spot on accurate for astrophotography. But if you do it reasonably well, then you're only going to have to worry about one movement going left and right. You don't have to worry about anything else. Because the telescope is, it's been aligned to the pole. So whereas if it's not, you have to worry about the two gears to follow and compensate for the Earth's rotation. If it's reasonably well aligned, you've only got the one gear to worry about once it's been aligned and fixed onto your object. So that's one advantage to having an equatorial. They are confusing sometimes, but that is that's the theory behind them. And they also have to be level. So before you put your mount on, or check to make sure it's level using a spirit level. If it's slightly off and you try to align it, then it's going to be appearing to do a circle around the pole, and you're still going to have roughly the same kind of problems as before. But I mean, if you're just looking to observe something for an eyepiece and don't want to have to keep on being like a DJ to twiddle the knobs to keep things in field of view, then align it as best as you can. And our Azimuth telescope owners, I'm sorry, but this isn't going to be of any benefit to you really. But it certainly will be for equatorial telescope users. So if you get the mount level to the Earth, and then get the axis as aligned to the pole as you can get it, then it should be easier. And of course, this is the heavyweight astrophotographers are the ones who have then got the reticles through they've actually got a second telescope going through their polar axis, but actually accurately align it. I've got one of them. I'm that pedantic as well. But if it is worth going to the trouble there, because once you've done it, it's aligned, which means if you're going to be observing the moon or anything like that, and especially for observing the moon, it would be useful to put a webcam in and have a bit longer to appreciate and marvel the view and focus a bit more on focusing rather than keeping it in field of view. That's the advantage there to align, and even roughly, it will give you a bit longer. It will hang around in your eyepiece for a bit longer before it drifts. If you're driven. If you're not driven, you'll need to use your worm gear to keep moving the telescope, but it won't be so hard if it wasn't aligned properly. So something there to keep in mind for you. And that's what the Northern Celestial Pole is all about. So, and I mentioned the term circumpolar before as well, didn't I? Well, what did I mean by that? Well, if I zoom out a little bit so we can get the full majesty of Ursa Major there. There we go, as close as we can get it. There we go. And then I'm going to turn my time machine back onto full pelt. It should be reasonably apparent, in fact that maybe is a bit too fast. Let's go to 3,000 times. That some stars, some constellations don't actually set, as we saw when we were looking south. The Ursa Major, or the Plough, doesn't set below the horizon. At least the frying pan part doesn't anyway. They just go round and round. Whereas when we were looking at the south end, they did set. So here we've got. So from the point of view of amateur astronomy, not very interesting at all. I mean, once you've bagged everything in that part of the sky, that's it. You've got that 365 days of the year. Well, a lot of people prefer a south-facing garden. So it's not just for the point of view of being a keen gardener, as we obviously with the south end facing garden, you're going to get more sunlight, which plants like. But it's also with the point of view that new objects are constantly coming into view here, which is why people prefer south-facing gardens. So north-facing is a bit more difficult. It's not a dead loss if you've got north-facing garden, because you can still catch things going over your head. Just a bit more difficult navigating to it, and you'll miss out on an awful lot of things which are behind houses and so on. But hopefully that's given you a bit of an overview of what's up in the night sky, and a bit of an overview on the celestial sphere as well. I hope it's been informative for you, and thank you for listening and watching.